All right, class, for today we are going to be talking about the target, HG7, which talks about finding equations of lines and talking about parallel lines, kind of what happens there. A while ago we had taken a pretest and it involved finding equations of parallel lines when you were already given an equation and a point, and you had to find a perpendicular line to a certain equation and a point, and I had said that we were going to revisit this eventually. Well, eventually has finally come, and we're going to actually learn how to find those kind of problems. So we are going to start with something called slope-intercept form. You've probably seen slope-intercept more often than any other form, and our equation looks like y equals mx plus b. So now I kind of want to pick apart some of the pieces in this equation. My m represents my slope, and my b represents my y-intercept. Based off of that information, we can kind of see why it's slope-intercept form. It's just saying those are the pieces that we want to look at. My y-intercept can be thought of as the spot where the line crosses the y-axis. So then the slope is described as the horizontal and vertical change from one point to another. Something even more commonly heard is rise over run. So when we want to find the slope, we have an equation that we can use to do just that. So I'm going to start with the letter m because that's how we use to represent slope. I want to talk about my vertical change, which in this case I'll say is y2 minus y1. And then talk about my horizontal change, which in this case is x2 minus x1. So again, the top is my vertical change. Bottom is my horizontal change. To kind of see this on a graph, I'm going to have 2 points here and a line that goes through them. Here, I can kind of make a triangle to connect the 2 points. The distance that I travel up and down would be considered my rise, and the distance that I travel left or right is what I consider to be my run. So now, let's say we want to actually find the slope of something. So in this case, I'm going to give you 2 points. And these points are going to be 1, 2, and 3, -4. I'm going to start by notating the different parts of my points just so I can kind of keep my pieces straight. So I'm going to start with x1 and y1, x2 and y2. So now I can just kind of plug right in and solve. So my y2, I have listed as -4. I'm going to subtract my y1, which is 2. So then when I want to find my x2, make sure that it is paired with your y2. We want to make sure that we're starting with the same coordinate point. So then I plug in 3 minus 1. And I can kind of simplify down a little bit. So this will give me -6 divided by 2. Simplifying one more time gives me a slope of -3. So now I'm going to ask you to take it one step farther than what we already have. Next, I'm going to ask you to find the equation of the line that has these 2 points. So when we kind of take a look at our equation, y equals mx plus b, our y and our x here represent coordinate points that we've been given. So in this case, we can just plug in an ordered pair to find what B is supposed to be. So if I do just that, I'm going to take we'll talk about Y1. So I'm going to take my Y, which is 2, my equal sign. We found that my slope was -3. So we'll have -3 times x, which in this case is 1, plus b, because I don't really know what that is yet. So from there I can simplify. 2 equals -3 plus b, because -3 times 1 will always be itself. Then I want to cancel out this 3, so I'm going to add 3 to both sides, which gives me 5 is equal to b. So the equation of my line with the slope and intercept would be y equals -3x plus 5. Now that we have found the equation of that line, we're going to talk about another form that we can use to do just that. So this form is going to be point-slope form. And this is kind of a longer version of our y equals mx plus b. So I'm going to start with a regular old y, and then subtract y1. All of that is going to be equal to m, which is my slope, times x minus x1. So to kind of talk about the pieces in this equation here, our m will be slope, like we knew before. Now the new pieces to talk about are my y1 and my x1. These will be given to us from a coordinate point. So again, this is point-slope form because we use a coordinate point and the slope to find the equation of our line. Something that is worth noting is we will not write our final answer in point-slope form. Our final form will always be y equals mx plus b. This just kind of gives us a starting point to find y equals mx plus b. So let's say, use an example. I'm going to tell you that the slope of my line is -3. And I'm going to give you a single coordinate point to work with, which in this case will be 3, -4. So again, this is my x1 and my y1. I'm going to plug right in to my point-slope form. So my point-slope form starts with y, and I subtract y1, which is -4. And all of that gets set equal to m, which in this case is my -3. And it's going to be multiplied by x minus x1, which in this case is 3. Now I can simplify this a little bit. My left side will turn into y plus 4 because I am subtracting a negative. Then I can simplify my right side, which turns into -3x plus 9. So then I'm just going to subtract 4 on both sides, which leaves me with y on the left. Nothing happened to our -3x, so I'm going to leave that as is. Then I can simplify 9 minus 4, which gives me 5. So this is another way to solve for the equation of our line, except instead of starting with 2 points, we were given the slope and one single point to work with. There is one more example that I do want to cover because it is something that you'll see quite often. So we're going to start with a new example. I'm going to give you 2 different coordinate points. We'll say 2, 6 and 3, 8. So I want you to write the equation of the line. So the first thing that I want to do will be find the slope. Once you find the slope, then we want to find our y-intercept through either point slope form or through y equals mx plus b. I'm going to use point slope form just so we can kind of practice it a little bit more. So the equation to find my slope is y2 minus y1 for x2 minus x1. So I'm going to take 8 and subtract 6, and then take 3 and subtract 2. When I simplify, this gives me 2 over 1, which gives me a 2 for my slope of m. Now again, I'm going to use point slope form to figure out the rest. Point slope form had started out with the letter y, and I'm going to subtract one of my points. I'm going to work with 2, 6. So I subtract my y1, which is 6, and that is equal to my slope multiplied by x minus my x1, which is 2. So then when I simplify, I have y minus 6 on one side, and then I am left on the right side with 2x minus 4. So then simplify some more. I'm going to add 6 on both sides, which leaves me with y equals 2x plus 2. That, my friends, is how I can start with 2 little points and somehow create a whole line and find any possible point on it. So now that we've gone through some examples, we're going to kind of talk about some special lines that we can see when we talk about slopes. I kind of touched on this a little bit in the start of, I think it was Unit 2. And we're going to kind of talk about them again. So the first special line that we have is a horizontal line. A horizontal line runs from left to right. In this case, since it's moving from left to right, when we think about our rise, we don't have one. Our rise is 0, which means 0 divided by any number is still going to equal 0. So when we want to actually write the equation of our line for a line that just runs left to right, our point would be y equals whatever the y-intercept is. So if I have a graph here, and my graph runs left to right, and it crosses at 2, this would mean that the equation of my line is just y equals 2. Because there's no slope, so we can't show that it's changing in really any way. The other half to that coin is when we have a horizontal line, we probably have a vertical line somewhere. So a vertical line runs up and down. And when we write the equation for this, we're going to start with x equals, and it's going to be whatever our x-intercept is. So again, if we look at a graph, I'm going to look at x equals 2. So 2, 0. And my line is actually going to run vertically. So in this case, our rise kind of travels forever and ever, and we really don't have a whole lot of information other than that. But when we look at our run, we don't have a run, which means in this case, we would divide by 0. But hold up, we can't divide by 0. That's like breaking the math law. probably one of the number one math laws. So when we talk about the slope of a vertical line, we want our line to be called undefined. And the equation of this line would be x equals 2. Our last piece of information for today is going to be all about equations of parallel lines. So this is kind of our special topic for the day. It'll be pretty short. It still kind of follows everything else we've talked about so far. The thing we need to know when we have equations of two lines that are parallel, parallel lines will always have the same slope. And same is kind of that big key word there. So there will be times where I'll ask you to find the equation of a line parallel to y equals negative 3x plus 5 and travels through the point negative 8, 5. Holy man, definitely had some words to write down and some words to piece through. So the first thing that we want to do is we know that parallel lines have the same slope. So I'm going to kind of zero in right here. The only piece of information that is important to me in y equals negative 3x plus 5 is my negative 3. Nothing else matters to me here. That's the only piece that I need. So the slope of my line has to have a slope of negative 3. So then in this case, I'm given a slope of negative 3 and a point of negative 8, 5. And I have to find the equation of the line. So I'm going to use point slope form for this just to kind of make sure that we feel comfortable. So again, that equation is y minus y1 equals m times x minus x1. So to kind of plug and chug and continue on, I'm going to have y minus my y1, which is 5, equals negative 3 times x minus negative 8. So then I have y minus 5 is equal to negative 3x minus 24, because I end up combining my two negatives to create a positive. Then negative 3 times a positive 8 is negative 24. I'm going to make sure to add 5 to both sides. So then when I simplify all the way down, I'm left with y on the left equals negative 3x for slope minus 19. So as we can see, the slope here matches our slope up here, which means this line is parallel, even though our y-intercept is different. So even on a graph, these lines will never, ever, ever touch. Next time, we are going to kind of talk about what happens when we have perpendicular lines and the situation that we have that unfolds there. With that, there is a daily practice set in Schoology that you can work on. Good luck, and if you have any questions, my door is always open. Just feel free to let me know.